Hello all. In this video we will solve the numerical for round robin CPU scheduling algorithm. So we have to calculate average waiting time and the algorithm is round robin. Now in this round robin CPU scheduling algorithm we need to know the time quantum or time slice, and let us say it is defined to be 3, right? Now round robin is also called as FCFS with preemption. Okay. And we are going to make use of a FIFO queue. We are going to make use of what? A FIFO queue. And the order of execution will be shown through a Gantt chart. So we start at time 0, right? And at time 0, we have only one process, and that is C. So that is inserted into the queue. Since there is only one process in the queue, naturally that process will get CPU. Now the role of time quantum or time slice is that time slice is defined to be 3. It means that no process will be given CPU more than 3 time units in one go. In one go at a time, a process can get CPU for at most 3 time units. So C will use CPU up to 3 time units. Now, what happens that in this duration 0 to 3 at time interval 2 or at time unit 2, process A arrives. So A is inserted into the queue. And at time unit 3, we realize that C's execution is not yet finished. The leftover time for C happens to be 5, right? So C should be inserted back into the queue. Then naturally it is a first in first out queue, so naturally A will get CPU now. So A will use CPU for the next 3 time units, so that is up to 3 to 6. Okay, but what happens in this time interval from 3 to 6 is at time interval 4 D arrives, so it is inserted into the queue, and at time interval 5 B arrives, so B is inserted into the queue. Okay, and then at time interval 6 we realize that A's execution is not yet over. It is left with one more time unit, right? Its total requirement was 4. It has already executed from 3 to 6, that is 3 time units. So we are left with one time unit for process A. So A is inserted back into the queue. Then naturally C will get back the CPU. C will be given CPU for next 3 time units. Okay, but what happens in this time interval from 6 to 9, at time interval 7 E arrives, so E is inserted into the queue, and at time interval 9 C's execution is still pending for 2 more units, so C will be inserted back into the queue. Then the queue is first in first out, so naturally D is removed from the queue. You give CPU to D. D will use CPU for next 3 time units 9 to 12, and the leftover time for D happens to be 2, right? Now no more processes arrive now. Okay, so we have to deal with the existing set of processes. Okay, so D uses CPU for 3 time units. D is not yet finished, so D will be inserted back into the queue. Then B is removed from the queue. B want to use CPU only for 2 time unit, right? So it will use it from 12 to 2, that is 14. 12 plus 2 is 14, and B is not inserted back to the queue because B has finished, right? B has now finished. Then if we remove A, we want A to get executed only for one time unit, right? So that is up to 15. Okay, and then A also finishes, so A is not inserted back into the queue. Then E is removed. E exactly want to use CPU for 3 time units, so it is given, so that is up to 18, and then E also finishes. Then we have C. C want to use CPU for 2 time units, so that is given, so that is 20. Okay, and C also finishes now, and finally CPU is given to D for 2 more time units. because D wanted to use for remaining 2 time units, and D also finishes. So this is the order in which processes will execute. Now let us calculate the wait time for each process. A, B, C, D and E. So what is the wait time for process A? Right? A came at 2, as you can see here. A came at 2, got CPU at 3, but didn't finish. From 6 to 12, sorry, 6 to 14 it was waiting. 6 to 14 it was waiting. So for how much amount of time it wait? 6 to 14, the difference happens to be 9. Okay, for 9 time units it was waiting. Then when you think of B came at 5, as you can see here, and got CPU at 12 and then finished, right? So 5 to 12 it was waiting, so that is 7. Okay. C came at 0, got CPU also at 0, but didn't finish. It was waiting from 3 to 6, so that is 3 time units. And then again from 9 to 18, it was also waiting, 9 to 18. So that happens to be another 9. So that is 12. Okay. Then process D. D came at 4, got CPU at 9, so that wait was 5. And when it got CPU at 9, it didn't finish. From this, for this much duration, from 12 to 20, it was again waiting. So that's 8. So that is 13. Okay. And finally we have process E, which came at time unit 7, got CPU at time unit 15, and it finished. So it was waiting from 7 to 15, so that is 8. Right? If we add all these values, those values happens to be 25 plus 8, 33, 33 plus 7, 40, 40 plus 9, 49. So this is the total wait time. If you divide it by number of processes, it would be 9.8. So the average waiting time for round robin for this example happens to be 9.8. Okay, I hope you have understood this. Thank you.